Okay, so before we have been talking about the insertion into the B plus tree. After we insert the nodes, we may create some nodes which may exceed the maximum number of keywords allowed in each node. Besides insertion, we also have to delete some of the keywords. You may wonder why we have to do delete in the B plus tree. The main reason is because during the running time, as we have more and more queries, and we have to create a very large index table, which may affect the efficiency of the queries in the future or not. Also, some of the queries we queried before, we will never query them again in the future. In the system, we detect some infrequent queries. If some of the keywords are very infrequent queried, and then we also will delete them to maintain the index table into a smaller size. So that's the reason why we also want to delete some of the entries from the B plus tree in the index table. And how can we do the deletion in the B plus tree? And if we delete some of the keywords, we may create some of the nodes whose number of keywords is smaller than the D, the constraint. If this happens, we have to do some organization of the nodes inside the B plus tree. And we can show you some examples to illustrate the algorithm we can use in the B plus tree for deletion of the keys. And we are still working on the same B plus tree we have before, and here we plan to do the deletion of 30 is key from the B plus tree. And the process will be very similar. The first step is to find the position for 30 in the B plus tree, and then we can do the deletion. So from the root, we can go down to a different node, matching the 30. We find 30 is in the B plus tree right now, and we'll do the deletion from it. So the deletion process is very simple. We just delete these keywords as well as this pointer from this node, and we'll shift the remaining entries to the left-hand side inside the nodes. In other words, after we do the deletion of the 30, we have to change this 40 and 50 the position to the left-hand side, or to move the pointer to the left-hand side. And after we do the deletion of this 30, how about the nodes in the parent node? This 30 here. Do we have to delete it or not? Actually, you can either change it or not change it. It will not affect our performance. The main reason is because these keywords in the parent node, in the internal nodes, they are just used for the comparison, for the range comparison. It's very different from the keys here, These keys can match concrete data tuples. However, the keys here, they just compare the keys, It denotes some keys, if it is larger than 30, we can go to the right-hand side, this branch. If it is smaller than 30, we can just go to the left-hand branch, If we change this one to 40, it doesn't matter, We'll still just follow the same comparison here. Therefore, this B plus deletion algorithm provides us with some flexibility. Either change this 30 here to 40 or not, it doesn't matter. Okay, so about deletion of the 30. If we do one further deletion about 25 in the B plus tree, how can we do this? So this process is similar. We just go to the root and find the entries matching 25 as such a key, We'll find it here, and we can delete it from these nodes. So after we do the deletion, the problem will be happening, Because if we delete this 25 from this node, inside this one, we only have one key, In other words, the keys inside this node will be smaller than the minimum number of keywords allowed in the nodes, It should be in the range from D to the 2D. The D here equals to 2, And this one has only one key, it is smaller than D. So to handle this problem, the algorithm in the B plus tree allows us to do one operation. It's called rotate. We have to rebalance these nodes in the B plus tree. The rotate process is like this. We search for the nearby nodes, The spinning nodes. We find on the left-hand side we have one node. Inside we have so many keys. If we can borrow one key from the left-hand side, from 19 to this right-hand side nodes, and we can resolve this problem hopefully. This operation is called rotate. So after we do the rotate, we have to move the 19 from left node to right node, it will move the pointer to the right node as well. And after doing the rotating, please be careful for the nodes in the parent node. We'll make some changes here, because this one, before we have 20, right? If we do the rotate, move the 19 to the right node, we will have to move the 19 to the parent node as well, because the 19 is smaller than the 20, right? However, we move to the right node. Therefore, we have to change the parent node to the 19 as well. This is very important. Please be careful when do the rotate. Okay, so it's about deletion of this 25. Let's say if we plan to further to do one deletion of 40, right? If we delete 40 from the B plus tree, what will happen? So after we deleted the 40, right? Inside this node we only have one entry. It's 50, right? In other words, this node will be illegal. The number of keys inside is smaller than D, right? We have to do some operations. And we'll try to do the rotation from left hand side. I will find that left hand side and the nodes, if we do the rotation, this one will be illegal. We have to do one further rotation, right, from left hand side. And it will create some cascading rotation. It will be a problem. Therefore, to avoid this cascading rotation, we plan to do the merging instead. In other words, we can merge these two nodes into one node instead. The merging process is very similar. We just move this 50 to the left hand side, this node, and also move the pointer to this node as well. And we can merge these two nodes together to create one new node, 19, 20, and 50. And after we do the merges, be careful for the nodes here, the 30. We have to delete this 30 because inside this one we have nodes which is less than 30 or larger than 30, right? And this 30 will be not useful anymore. We have to delete it from the parent node as well. And this will be the new node created for us. And we'll have one point pointing to this new node from the left hand side. And we have one point pointing to the right hand side node as well. And inside this new node, all pointers will be pointing to some concrete data tuples matching such keys in the systems. Okay, so it's about deletion in the B plus tree. So when we do the deletion, if we have some illegal nodes, we have to do either rotation or the mergers. We have to be very careful for the keys in the nodes, especially the ones in the parent node. Okay, so I hope you can follow me, right? You can go over the examples by yourself to try to do the deletion as we insert in the B plus tree.